So now we are going to discuss the challenge of software-defined cars. Yesterday, we heard about how software will become the central battleground for companies from Oliver Hayden at Press Relations. Hartmut Eierle from the Ivy campus at Bruxelles said he doesn't expect the current chip shortage to be a major problem going forward. Well, let's take a closer look at the challenges of this type of mobility. I would like to now welcome Hari Haran Venkita-Shalam. He is the technology manager at the ZF Group and a visiting lecturer at the University of Dortmund. Welcome, Hari Haran, to the program. And a warm welcome also to Joost van Toom. He is the Smart Mobility Director at the European Automobile Manufacturers Association. Welcome to you, Joost. Hari Haran, I would like to start with you. Can you hear me?
Yes, I can hear you.
Great. I want to ask you, why is software key for the cars of today and tomorrow?
Software is essentially seen as a facilitator to ensure the new upcoming themes in the automotive industry, which is essentially connectivity, automation, and also electric and shared mobility. So it's essentially seen as a facilitator. Imagine if you think about driving across to a workshop and you want to rectify some parts and there's some damage to some of the parts and so on. Today with software, you can actually update this over the air, make sure that the software is working inside the vehicle and so on. So the infrastructure for this is already available. And this enables you to actually fix problems earlier. This has enabled new business models, new monetization methods, and so on. So as a result of which you have, of course, a lot of possibilities on one side, but it also poses a lot of challenges. And of course, these are the challenges that are related to, say, cybersecurity. It's related to protecting a lot of consumer information. It's also related to how you store the data, how you transmit it, etc., etc.
Joost, a warm welcome to you too. I want to ask you, how expensive will this be for automakers exactly?
Yeah, thank you for inviting me. That's a good question. I would say it's difficult to put price tags on all this. I can just say one thing, and that is something that will be very clear towards European policymakers, the Commission, Parliament and Council. Every time they ask us to add features on ADAS or even automated driving on general safety, active and passive general safety systems, everything comes with a cost. The suppliers, component, are passing on the cost to the OEMs. The OEMs obviously pass some of the cost, if not all, to the client. So everything has a cost, and especially when we depend on much more connectivity. We haven't talked about the cost of connectivity, but also this comes with a price tag. It's not only about small bits and bytes that we are sending through cellular or short range. Tomorrow will be big data that we're going to send, and especially for automated driving, the computing power will be edge computing. So all this, again, comes with a price tag, and I cannot put a figure on that, but I can just say that everything we get new obligations and new additions to mandates in all areas for vehicles, it will not be free of charge. That's clear, and there is no free lunch on this.
Joost, if you can, tell us about the state of the industry worldwide in this sector.
Wow, how many days do we have on this one? Well, first, we come from an isolated industry producing vehicles. It's metal, it's design. We just heard it about software didn't exist, I think, 30 years ago. It was just firmware, a bit of hardware, well, all hardware. We moved then to a big transition. The first transition was in terms of new types of engines, new types of models, also how to interact with the outside. And now, since I would say 10 years, we have discovered, well, we have seen that vehicles are part of a new ecosystem. That's not a buzzword, that's reality. What I see with all my OEMs, all 16 of them in Europe, all the headquarters, they will have large software teams, large teams dealing with AI, with access to vehicle data, with the extended vehicle model. All these guys are not doing the vehicles anymore. They're doing things, how can a vehicle interact with the other parts in the society? It can be V2V, V2I, V2X, all kinds of communication channels with third parties. And this is very beneficial. So, and we see it also not only in Europe, where vehicles going into connected and cooperative modus. We see the same trends in the US. I was recently invited again in China through a webinar then, unfortunately this time, but every year they have this cycle of conferences with government and Europe on where does Europe stand on this and where is China going. We see similar things in Japan, where actually we have the first level 4 automated driving car already approved, it's type approved. So it's going at a rapid pace. The good news is that we all have the same questions also, the same existential questions that we have to look at and try to solve with the industry and society.
Hariharan, if you can, give us an idea regarding the complexity and sheer amount of volume data that's required.
Yeah. So as you mentioned, there are automotive industry has gone through a huge transition. I mean, over the last 100 years, we've had mechanical, electromechanical controls. Then we had mechatronic controls. Then we started networking them with each other through communication protocols. Then after that, we've had now external interfaces like car to car, car to X, and such kind of things. And as a result of which, data has become a core component of our new vehicle ecosystem, so to say. And when you look at the modern car, which is a high-end car, so it has around 70 to 100 ECUs. We're talking about roughly 100 million lines of code. And imagine updating the vehicle software on a daily basis for 100 million lines of code. And this has to be coordinated across, say, around 6 to 7 locations for each supplier. And then imagine there are hundreds of suppliers who are working together to make sure that the vehicle is functioning. So we are looking at tons of, I don't know whether it can be even quantified in terms of data. We are talking about this amount of data being transmitted across via wireless medium or being stored inside servers, made sure that this is the version numbers don't get mixed up, that the interfaces don't get mixed up, and all those kind of things. So the complexity of storing software data in servers and also transmitting across to the vehicle, and to make sure that this meets the local demands in terms of legislation, in terms of consumer expectations, etc., is a huge challenge which is faced both by the Tier 1 as well as the OEMs put together.
You just brought up the topic of legislation, and I want to ask you, Joost, what does this mean from your point of view for the regulatory side of things?
It's quite a challenge, to be honest. My background is also telecommunications and software in the past as a lawyer. So the question is rightly asked to me. And what I see in the vehicle business, the European Commission is struggling a bit on, say, well, should we intervene in that business? Should we legislate in that business? We have the semiconductor shortage issue. Can the Commission do something on this in this B2B environment? How to tackle cybersecurity, because that's a big elephant in the room we haven't mentioned, but cybersecurity and software updates over the year, how to tackle that? It's good to have legislation with tick-the-box exercise, saying that the company is secure, that the product is secure, that the process is secure, etc. But what happens if there would be a cyber attack and everything gets connected, vehicles getting connected to other vehicles and systems? You get actually the whole value chain will be disrupted and affected or infected. So from a legislative point of view, the Commission has tabled cybersecurity legislation. It's based on the UNEC, so based on international. And that's good because things should be tackled first at the international level, at the United Nations. We have dedicated groups, it's VP29 in this case, dealing with cybersecurity software updates with ALKS, so also for the automated driving. And then Europe as a region, like US, Asia, Australia, they should implement this in European law as is, not gold plating it. And that's actually what they are trying to do. The challenge in this data economy is what do we do with vehicle data? Yeah? Vehicles are producing a lot of data, a lot of terabytes actually. Today cloud computing, tomorrow edge computing. So should we regulate these data sharing issues? And the Commission is now thinking at developing a specific legislative act for access to vehicle data, vertical act for vehicles based on a fair access to data, fair sharing of data, without having OEMs, gatekeepers in the system. That's exactly what we embrace. We are not against any legislative act on that, but we just want to be sure that that cybersecurity and safety is key. And a vehicle is not a software platform. A vehicle is not a smartphone. You cannot reboot a vehicle while driving, for example. Yeah. So that's a bit what we see in terms of challenges on legislation.
Thank you for that. Hariharan, how difficult are these regulations from an engineering point of view?
Legislations are in general written in a very in a different language altogether. For engineers to understand it takes a certain level of effort. There's a lot of room for interpretation. There is also a lot of clarification which is required when it comes to legislation. So as a result of which, this leads to a lot of engineering effort on our side to clarify these requirements, make sure that we've understood it right, that we are implementing it right, and we need to also assess these whether these legislations have been followed to the right matter and spirit, and to make sure that the vehicle is validated. And at the end, we need to make sure that the driver, the pedestrian, the co-passenger, all the stakeholders in the vehicle ecosystem are safe and secure.
And Joost, regarding autonomous driving, what do you think is missing for this sector to really have a breakthrough? Is it engineering, legislature, or data networks, perhaps?
If we talk automated driving, which means that actually the car is driving you and not you driving the car, it's two things. First, it's indeed the regulatory framework in terms of type approval. For example, in Germany, in your country, there is now a new legislation from the BMWI and new traffic legislation as well to allow higher levels of automated driving. But that's only for Germany. My brands, also German brands, next week at the IAA, you will see them all. They work on a global scale. So it's not necessarily sufficient to have a German approval system. France did the same and UK did the same. That means 3 stages that you have to pass through. We would favor at least a European whole type approval. Now, that is based on the work that we have done with OICA at UNEC, so at Geneva, to have a framework for automated lane keep systems, so ALKS. That means that the car can stay into the same lane or change lane up to a certain speed, but in a purely autonomous way, automated way. That legislation should now be implemented in Europe, and that's actually what we're doing with the European Commission until the end of this year. So that's one thing that should be clarified so that we have a legal predictability for the OEM suppliers and the whole value chain on how to produce these things.
Well, when
the second,
continue.
The second thing is traffic legislation. People may not know that, but we are producing vehicles. Yeah, these vehicles is a product. Like any product, it should be approved, it should be certified, and so on and so on. That's fine. So suppose that you have an autonomous product, a robot car, a robot taxi, or a truck platoon. That's fine, but if traffic legislation does not allow these vehicles or does not allow you not to take attention to the traffic and to do other things in your vehicle, then what's the usefulness of such products? Because you're not allowed to use them. That's why at the same time we're also advocating to the member states, to the countries, to the transport ministers, to say, please also upgrade your traffic legislation to allow such kind of automated systems.
That brings me to my next point about connectivity of autonomous vehicles. How do you imagine the transformation from the mobility of today to autonomous mobility when, like you said, some cars are autonomous and some are still driven by humans? Is this complicated and maybe even perhaps dangerous?
I get these questions usually quite often. It's about the digital divide as well. We used to have people that are connected and people that are not connected. Even today, we have the digital divide on electronic invoicing, on people having an ID and others don't. And if you don't have an ID, you don't exist anymore. That's more or less how it works. And we have the same with the COVID, unfortunately, with the COVID area as well. You have the vaccinated and the non-vaccinated, and how you deal with these ethical dilemmas. We will see the same, and we have the same discussion with cities, with the infrastructure operators, with the road operators, on how will you allow automated vehicles or higher levels of automated vehicles and connected versus the non-automated ones and the non-connected ones. Yeah. How will you ensure that there will not be a disruption and also a gap between the people using automated and not automated? Will you have separate lanes, like the taxi lanes in some countries, like the bus lanes in some countries? Will you have automated lanes? I don't know. Is that the best throughput of traffic? We're still discussing that also with ERTICO and with the ITS. The ITS Congress will also discuss this in Hamburg very soon. So these are first valid questions without any specific answers today, but it's on the table, that's clear.
So it's all about bridging the digital divide. Yeah. Hariharan, of course, everybody wants connectivity and a smooth experience, but what are the limits regarding data security?
So data security, as you also mentioned, is pivotal to ensure the confidence of the users, so to say. So it's always a balance between extracting necessary information to improve the quality of services on one side, and to make sure that the data, say for example, critical data like credit card information or something like that is secured and stored in secured servers and made sure that it cannot be hacked into on one side, and on the other side to make sure that you have new models, business models evolving out of it, like remote diagnostics, or say for example in terms of fleet management, in terms of location aware services and so on. It is always a tough balancing act that has to be done. And that is where I believe there's a lot of work to be done, both on the engineering side as well as on the legislation side of it.
Let's talk a little bit more about the engineering side. What challenges do engineers face in that respect to get all the different data and structures to work together?
Yeah. So if you think about, say, for example, the new interfaces that are there for the powertrain. So if you think about, say, car to car or car to X or something like that, most of this is provided by third-party providers. So most of this is provided in a data structure which is completely different from what we are used to in terms of traditional electronic control unit development. So interfacing this from a time perspective, interfacing this from an understanding perspective of how to make sense of this particular data, and then adjust your controls in such a way that you can actually do a closed loop control with an external entity which is sending you data. This is going to be a very, very big challenge for engineers. And most of the times this has to be tested in a wide variety of, if you want to deploy it worldwide. So for example, you need to make sure that there is a standardization of data. There is also standardization of the understanding of how this data is being transmitted across, how this can be securely accessed, and how this can be utilized in terms of the control algorithms to make sure that the control algorithms are working correctly in tandem with this particular data. So this is the key engineering challenge.
With big data comes big challenges. Those vast amounts of data have to be shared also between different companies in different countries. It sounds like a challenge, so just tell us exactly how big is this task?
It's a big task because every vehicle produces thousands of codes and lines and data sets, and they're all different. Every type, every brand, every mark. First, we need to discuss that. Are we talking the same language? Are we talking, for example, mileage or kilometers per hour? Are we talking miles or kilometers? So that's the metadata. And that's something we are now working on. We have quite some working groups on that and standardization on. And first, let's understand each other. Let's see if we talk the same category of data. Yeah. And secondly, in terms of data themselves, that's quite a challenge to standardize it. We are not really in favor of standardization of all these data sets because every vehicle is different. Every IoT instrument is different, by the way. So we should not have a one salami tactic that everything would be the same. Otherwise, you would drive competitiveness out of Europe and out of our industry, which is one of the most competitive industries in Europe. But we do want to have a discussion on metadata and also on if we talk about the ecosystems, how to have a good platform discussion on this. We see Gaia X in Germany and Catena X as well. We see AI applications in other countries. Do we need a European Gaia X, for example? And that is exactly as we speak. We discussed this with the European Commission to have to elevate the German-French initiative to a European level, to have a house and a roof to exchange these data sets in the mobility data space.
So yesterday we heard from Hartmut Eierle from the Ivy Campus Bruxelles, and he said that he doesn't think that the chip shortage problem will be a large problem going forward. Hariharan, in your opinion, is that correct?
Yes, it's a temporary issue which has been caused due to the current situation with COVID. That there are certain plants which have been shut down from the semiconductor manufacturers due to the health situation which has arisen. This will take some time, but nobody can clearly say exactly when this is going to recover and so on. But this has also proven to us that our supply chains are extremely global in nature. So as a result of which, we are facing extremely huge pressure in terms of the semiconductor crisis in the automotive industry. And I believe it will rebound at some point of time, but the exact timeline for me is not clear.
Joost, is there anything you would like to add on the topic of chip shortage?
It's a huge topic. When I see all my OEMs, the latest board meeting was clear. All CEOs have the same problem. It's about the critical dependency of European operators from non-European countries, mostly Taiwan and Korea. I think we only have a few chip manufacturers in Europe, at least NXP and maybe some others, but that's it. And that's a bit the issue we have. We have the same issue with hyperscalers. So the GAFAs, we don't have a European GAFA. And that's with Commissioner Breton really hammering out to have a European data economy, not to be too much dependent on the non-European side. But the chip shortage, I hope it's not there to stay, but it's as worse as the COVID impacts. We have to stop plants, whole plants. You see all the brands have that issue. Employment issues, supply chain issues. It's really like Harihan said, it's like the Suez Channel has also been closed for the ships there due to a breakup. We also have felt it. So everything is interconnected. There is no silos anymore. There is no national champions. It's a global industry. And so we all have dependency on each other.
Okay, that was Joost van Toom and Hariharan Venkiteshalam. I thank you very much for your time.
Thank you. Thanks for the opportunity. Bye.
We are now going to take a very short break. Don't go anywhere. We'll be back in about 7 minutes. See you then.